All right, good evening, everyone. Welcome. So we'll get started. So yesterday we had seen creation of databases and how we can create a table within a database, and we inserted few records into the table, right? So today we are going to run few queries onto the MySQL workbench. So let me start first running that. So first thing is select, or even before that, let's select the database. In order to select the database, I select something like this. So we had created a database called as Kirana DB, and this is what we will be using. So I would use Kirana DB here. And then we will try to run queries here before we start using the tables. So first thing is we'll use a function called as cached function. Okay, so this takes some input. The cached function takes some input. This is an inbuilt function in MySQL. So functions are also present in SQL language as well. We'll see what it means. We had seen in Python that what functions are. So similarly in SQL language as well, we have certain functions. So I have select cached, and then we are going to pass some value to it. So I pass pi to it, and I want to cache it as a floating value, right? So this is what I have done here, and I run this particular statement. So select and then cached pi as floating value. So it gives us a value as 3.14159. That is the value that we get here, right? Select cached pi as floating value. Now we have done this, and then the next thing that I'll try to do is cached some string or character value. So let me try to do this. Select cached, and a string value is generally enclosed in single quotes or in double quotes here. So I'm using single quotes, and I would use hello and then provide some spaces. Okay, as char of 10. So char of 10 means characters of value 10. So I've given this and then execute this. So if we look at this, this is what is the output we get as hello, and the extra spaces are trimmed off. That is what we see in this particular casting. Casting or cached function essentially converts one type to another type. That is what we are trying to do here. Okay, that is what cached does. Similarly, if I use something like this, cached of, again, I use hello, and I provide space, and then use a variable character data type. And then I take a size of 10 and then run this. Okay. So this time when we ran this, select cached of hello as varchar or varchar. This gave us an error. If you look at the action output below, this gives us an error, right? This gave us an error. What this means is that it is not really a correct way of representing this, is because varchar cannot be casted and cannot be passed into cached, right? That is why we get an error. So cached functions only allow certain data types. It doesn't allow all the data types that are available in MySQL. So we'll look at these kind of castings or transforming from one data type to another data type as we go further. Okay, that is what we'll try to do. As we go further, we'll look at them. Okay, so this is what we have. And as we go further, we'll look at these functions at various occurrences, and we'll see how to use them. But even before we start using functions on the columns or on the values that are there in tables, we'll try to understand what it means to use a table and how do we use a table. We'll look at some of the DML commands and the DDL commands as we get into slowly into the various usages of using DML and DDL commands on the table itself. Okay. So what we will do is we will try to do certain queries on the table itself. So what I'll try to do now is I'll create one more table in the Kirana DB. And this time the table would be called as items underscore null. We'll maybe drop this table later. Okay, I create something like this, items underscore null. Okay, this is the table name. So how do we create a table? We use create table name, right? And then within this, after the name, we provide this parenthesis and end with a semicolon. And within this parenthesis, we have the column names and their respective data types. So first thing is, what I'm trying to do is we'll introduce the data type. So I'll call items and or probably item ID. I'll not call items because we already have a table. So, and the data type for this item ID is int. And we will try to deal with null values or not null values. We have already seen what null values mean. Null value essentially means that there is no value to it, right? It is not empty space or some kind of unknown value, nothing like that. It's just that no value is present. That is what is a null value in SQL. So now I'm trying to enforce or probably give one constraint to this. What I'm calling this is basically a not null. This is present in MySQL, and we want to specify that item ID cannot be null. Or whenever we try to insert values into this table, or we want to add values to the table, the item ID cannot be null. That is what we are trying to provide this in the table. So create table name, and then the column name. The first column name is item ID, and the data type for that item ID is integer, and it is not null. Fine. And we'll add one more column to it. This is called as item code. And this is of integer type. Okay. And again, we specify something like this as null. So against this column item code, we are specifying, or let me make this in lowercase. So item code, and this is basically of type integer, and null values are allowed. For the first column, which is item ID, this is of data type integer, and null values are not allowed, or that is why we specified not null. If we want null values to be acceptable, then we can specify something like this, item code int null, right? That is what it means here. Okay, so we'll try to run this table. So I select this and use Control Enter, or we can use this particular symbol where we can execute the selected portion of the query in this query editor. Okay, I run this and then we have the table created. Fine. So once the table is created, next thing is what we'll try to do is we'll try to see if we can insert some values to this particular table. So first thing is we'll insert something like this, insert into items. So how do we add values? We can use insert statement. That is what we have seen yesterday. So insert into items, and item ID, I'm giving this as 111, and item code is 2323, right? This is what the item code for this particular table is. So I say insert into items value. Right? And we are providing the value for this particular table. This is one record that we are inserting. Right, so let me execute this. So let me say we create a table. By the way, I'll be uploading all of this code onto GitHub and then sharing the link for further usage. So the files would be available. So create a table with the specified column names. Okay, so now once the table is available, or if create table if not exists, right? That is something that we can add or we can modify. So insert items into items value 11, and the item code is 2323. So let me execute this. So this is items underscore null, not items. So yeah, this is items underscore null value 111, 2323. Let me execute this. So this gets inserted, right? So how do we know this? Select star from items underscore null. Right, we get the value as, or we see one record getting inserted into a table and the column names are displayed. Right, so that is what we see here. Now, next thing that I would like to do is try to change the way we have added elements. So I specify something like this, and then value. And the first thing that I'll do is I'll add 112 as the item ID and then null to it, right? And then we'll try to execute this. This gets executed. Let us again recheck the table, right? We see 111, 2323 and 112 as the null value, right? That is what we see here. And similarly, if I want to do the same thing with the same record, or I say items underscore null value 111 and null. And then I try to execute this, and then we try to see if the values are there. So 111 there is null, and 111 there is 2323. That is what we see here. Okay, so the values have been added to the table. Okay, let me try to save this later. So we have the values that have been added to the table. Now, null value is accepting, or it is accepting for the second column item code, because we have given that as null. So let us try to do the other way around. Insert into items underscore null. And then I add the value, something like this. The first value is null and the item code is 2324. Okay, that is what I try to do here. So, right, insert into the table is item underscore null value null comma 2324. Let's try to run this, and it throws an error, right? It says table kirana db dot item underscore items, right? Sorry. Let me try to run it again. Yeah. So it now says column item ID cannot be null. So item ID cannot be null, right? That is what it gives us the error when we try to insert a null value. Because we have forced a constraint on item ID that it should not be null, whenever we try to insert a null value, it will throw an error, right? This is the first thing that we see here. Item ID is throwing an error to us. So what should be done so that we see that this kind of behavior is also not present in our items table. Let's say we have items table. We have already seen how items table is generated or how it is created yesterday, right? If we look at the way the table was created, right? We had seen that. Let me try to run this again. Show create table items, right? Right. And if we try to look at this, right, and try to get the output here, right? So it has used this particular items as the table name, right? And it says item ID default is null value. That is what items is taking. Now, because it is allowing null values, we want to change this on the items table. On the items underscore null, we have made sure that null value is not accepted, but we want to make sure the items table also that is available. We already have items table. How do we know if items table is there? So let me try to run this. I'll just run this. Show tables in our database, right? Right? It shows items and items underscore null. There are two tables that are available. So we have items and items underscore null as two tables in this particular database, which is Kirana DB. Now, we want to make sure items also doesn't allow null values for item ID. For now, the default value is null. How do we know that? If we insert something to items, right? Let's say we are trying to insert something to items. So that will give us a null value, right? So let me try to do this. I take something like this, insert into items and then value. We have a lot of values for that. So let me try to see what are the values that we have. So we have first one is ID. So I provide this as null value. null value, and then we'll start adding the values to it. Null. The other one was Anjali, and then we had the product item description. So this is food, that is what I give. And then we had the description for it, or the manufacturing. Sorry, this was manufacturer. And this is some product name or the item name. So I would say this as, so let's say jam, and this is the manufacturer, and description is mixed fruit jam. And there was price and the units. Okay, so let me give this as 70, and then we have the number of units as, let's say the quantity that is available right now is 10. So let me try to run this, and we see this null is allowed, right? So if we do this, select star from items, right? So our last column that was inserted is basically for item ID, it is allowing null value. Now we do not want to have null value into our items table, right? We want to identify every item with a unique identifier, or it should not have null value, right? That is what we want to do. It could be a duplicate value or it could be something, but we do not want to add it. So what we'll try to do is that we'll try to change the way item ID column is represented. If we want to change the definition of something, right? We want to use another definition. Right now, item ID is allowing null. We do not want to allow the null value. Now, if you want to do this, what we are trying to do is we'll use what is called as an alter statement, using which we will be able to modify what was there with respect to the properties of a column, right? So first thing that we'll use is alter command, and then I'll use alter table, and the table name is item. Okay, alter table, the table name. Fine. And then what do we want to do is we want to modify the item ID column, right? So I will use modify item ID column. Okay. And here for modifying this, I want to specify this would be of integer type and it should not be null, right? So what we have done is we are modifying the item ID column with for the table items using the alter statement. Okay, we are changing the definition. So alter table items, modify item ID, and then the type of it, what do we want to present the type of it and what it should represent, or what should be the constraint that we want to add to it. The constraint that we want to add to this item ID is that it should not be null. That is what I'm trying to do here. So alter table items, modify item ID integer, not null. This was modify item ID. So this is wrong, right? Okay, so since we have added null value, now I would have to delete this particular null value, and then I have to make the modification for this, right? So now we already have the null value to the table, right? So this is not allowing us to modify now because there is already a null value inside the table. So this is not allowing us to change this particular type. So what we'll try to do is, let me try to see if I can change something for the table itself. This was allowing null values. Now we do not want to allow the null value. Okay, we should have to delete it. So what I'd like to do is All right, so we'll do one thing. We'll try to delete that row and then try to see how we can. But then I have not introduced it. But anyways, we'll try to do it. So delete from this items where item ID is null. Okay, so item ID is null, item ID is not getting selected. Okay, I think this is a safe update mode. Probably I have to enable it. Let me try to do that as well. I have to update something here. Just give a minute. So this is actually asking for disable the safe mode. See this one. Now this comes up. Let me try to disable the safe mode query editor and then okay. Let me try to reconnect. Just give me a minute. All right, so let me try to do this again. So let me try to use the database. It is not yet selected. So I select the database and now I try to delete it. Okay. So delete from items where item ID is null. Now this gets executed, right? Now I want to alter the table items, modify item ID int not null. Right now this gets executed without an error. So I had to change the safe update mode in order to work with the delete and then try to alter it, right? So, and if you want to do that, we can go to edit and here we have preferences. And within preferences, we have the SQL editor. And then at the bottom, you have to uncheck this. All right. So that helps us trying to modify the statement or the table for any kind of updates. Now we were able to run this alter table on items because null values was there. We removed it and then we tried to change the construct of the table or the definition of the table. Now that is what runs here. And let us try to reinsert this. Okay, the one that we executed earlier, try to do it now after we have altered the schema of the table, right? So alter into items value, then we have null value, right? So let me try to do this and it throws an error. It says that item ID cannot be null, right? So once we have this kind of constraint, we will not be able to insert data into the table where null values are not allowed, right? Item ID cannot have or it cannot have null values. That is why null is not being allowed to be saved or persisted in this particular table for the column. So this is how we can modify this. Let's say we want to add a column. Instead of modifying the existing attribute of the column, what we want to do now is modify the or add a column, one more column to the table. How do we do that? We can do something like this, alter table items. So alter table, table name. In this case, it is items. And then add. And then we have the column name. So I specify the column name and then integer. And then I specify this. This should also be not null. right? Alter table items and then add column name, then the integer data type, and this should also be not null, right? That is what I'm trying to do here. So now we have alter table items, add item code, the data type is integer, and then we have not null. Fine. So this is what we have done now. And let's see what is the table. So for checking what the table is, we can use the describe command and the table name. The table name is items in this case, right? So if we look at describe and also look at what the output is in the result grid, we get the column names for the field. Then we have the data types, right? And then we have whether null value is allowed or not. If we look at this closely, item ID says null value as no, item name is yes, etc. And for all the other columns is yes, except for item code and item ID. Right? And the default value, if we are not specifying, everything is being shown as null right now. Okay, the default value is being shown as null. So what we have done is initially we created a table. Then inside that table, we added certain rows, and then also we added null values to a particular column like item ID. And it was accepting the null values. But then we found out that null should not be allowed when we altered the table, because we do not want to have a null value for the item ID. So we alter the table, and then it does not allow us to add, or it does not allow us to modify the table because null was already inserted. So what we did was we deleted the data from the table using the delete statement. So we had delete from table name, and then this clause is basically where clause. We'll come back to this. For now, we have deleted it. So using where clause, we have deleted the record from the table. And then we modified the table with respect to the item ID column, wherein the item ID column was allowing not null value. So to do that, we used alter table name, modify the column name, the data type, and not null. And then we try to insert the same thing for item ID with the null value. It did not allow the second, right? So this is what we have done as the sequence of steps. Okay. The next thing that we did with respect to the items column was to add a column to an existing column. In order to add a column to an already existing column, we have to use the alter command or the alter statement. So alter table name, add column name is item code. It is of type integer, and this also should not allow null values. So we have specified not null, or it should have certain value when we are inserting the data into item code and item ID. Right? This is what it does. Now we have done describe item. It gives us the display of the data type, the column name, whether the null values are allowed or not, and what is the default value. The default value for all these columns is null. Even though we have specified for two columns, item ID and item code, it should not be null, but then it gives us the default value. Right? So let us try to check what is happening now. So select star from items. Right? If we look at the output now, item code has a value of 0 for all the rows, right? And there are duplicate rows also. For example, 9002, 9002 is repeated twice or thrice, in fact, thrice. 9001 is repeated twice in the output, right? That is what we see the data, and there are certain duplicates in the table. And that was intentionally done. We had inserted the data so that the duplicates are available. And for item code, please note that 0 is the default value that has been specified. Right? So this is the values that we get from the items table, or the item code value is 0 in the items table. Now that is what we have seen. Now, whenever we have this kind of output, right, where the data is duplicated and we have something like this, these are not generally the ones that are specified by EF chord, right? The first thing that we had seen earlier was what was called as chord rules, how data has to, or how an RDBMS has to be designed. Next one is how should a table be designed, and what are the best practices one has to follow for designing a database or designing tables within a database is something that we will try to understand. And for an RDBMS, EF Code proposed certain rules of how to design tables and databases. Those rules or those processes is essentially called as normalization. Fine. So we'll also look at what is normalization, and then we will try to create our tables from there and see what essentially it means with respect to normalization and how are we going to create those tables using these normalization rules or normalization forms. All right, so first thing is, before we get into actually what normalization is, we'll try to understand what is that a particular table needs to have. So whenever we try to define a table, we need what are called as keys, right? There are different kinds of keys that we will look at, but why should a table should have a key, or what should, why is that it will help in order to retrieve the data? What is that could be identified when we use keys? The first thing that we try to understand is keys. Why are they required? Now, in order to provide certain kind of constraints, we would need keys, just like what we had seen on not null, right? We do not want to enter null values for some identifier like ID. So we do not want null, so we use not null as a constraint. Similarly, if we want something else, we can use keys in order to specify those. And there are certain keys that an RDBMS provides to us so that we can utilize them. And why do we need keys? Point number one is that we do not, or we would want to specify certain kind of constraints for a table in a database. That is why we want to have a key. The second thing is we do not want to duplicate the data, right? We do not want to duplicate the data, or we want to maintain uniqueness of records in the table. For these reasons, we need a key. For example, if we want to identify a particular record with a particular employee, he might have a first name, last name, but if we want to identify what is that could be identified with a minimalistic data that is available, we can use what is called as an employee ID. Employee ID can be used as a key to identify a record in a table with a particular employee, right? Similarly, a house number or a flat number or an address can be used to identify the correct location of a particular address. Similarly, for a product ID can help us, or a product code can help us to identify the product. If it is a university or an office or probably a Kirana store, a department ID can help us try to identify what is the department that our employee belongs to. Okay, so these are some of the things where keys could be utilized to identify a record. Now, where do we apply these keys? Generally, keys are applied to a single column or multiple columns. That is where the keys could be applied. And why do we apply a key? So that we can maintain the quality and the consistency of the data that is stored in a table. That is why we want to apply a key to it, right? So the first thing that we have seen with respect to employee or employee ID is what we have looked at. That is again a key. We want to apply employee ID to the data that is stored. So employee ID can be used as a key to identify each individual record, right? We do not want duplicates in the table as well. So we use employee ID. Similarly, an house address or a flat number can be used for a particular address, right? Or a combination of a flat number and an address. If flat number is same across different apartments, then probably we can use a combination of flat number and the address code or the address location number in order to identify an address for a particular person or a particular house. Similarly, for a product ID with respect to a particular departmental store or probably a Kirana store, where we want to identify a product ID. Similarly, with respect to departments in various institutions, we use a department ID that can uniquely identify what that department is about, right? So it could be a code or it could be an ID. That is what it identifies a department with respect to an institution. So these are some of the things why a DBMS can be designed or how it can be designed using. First thing is keys, right? What are the different kinds of keys that we come across in database management systems or RDBMSs? There are different kinds of keys that we can use. The first one is the candidate key. Then we have the primary key. then we have the superset key, then we have the foreign key, then we have the composite key, then we have the unique key, and then we have the alternate key. So these are the various keys that can be used in a table within a database. So what are these different keys that can be used? So first one is the super key. Super key is something or it is a combination of different keys that identifies a record or a row in a database, right? And when we say a key, it is basically a column that we are referring to, or basically a attribute that is available with respect to a data set, right? Or with respect to a set of data that we are storing. For example, employee name is basically a key, or employee ID can be a key, or a combination of employee ID, employee first name, and employee last name can be a key, right? These are the three different values that we can use for referring to a key. So when we say a super key is nothing but a set of keys that can be used to identify a record. And is there something a minimum value? No, we can use all the keys that are there in a particular table and say this is a super key, right? The next one is a candidate key. Now, the difference between a candidate key and a super key is that candidate keys uses minimal set of attributes or values or the number of columns that we use. It is a minimum number of columns that helps us identify a record and makes it distinct from other record or other row. That is what would be a candidate key. Okay, so it is the minimum number of values or attributes or columns that we consider in order to make the record unique and it is distinct from the other record. Okay, that is what would be a candidate key, and we'll look at examples as we go further. Then we have a primary key. Now, from the candidate key, if we can identify one or more keys, so that becomes the unique identifier for a particular row or a record. Let's say we are dealing with student table. So for a student, roll number would be sufficient to identify. That could be used as a primary key. For a candidate key, roll number, to first name and last name can be used as a candidate key. And what is the super key? Roll number, first name, last name, and the department that he belongs to can be a super key, right? So candidate key is generally a subset of super key, or the minimum number of values or keys or columns that could be considered from the super key that could be used as a candidate key. Primary key is the one which is taking from the candidate key to identify a particular record as unique or not, right? That is what is the primary. Then we have alternate key. Alternate key is nothing but all the keys remaining after the primary key. If we remove primary key and if there are other keys, that would become the alternate keys. Then we have a composite key. Now, a composite key can be considered as a key that could be used for identifying a particular record uniquely. Now, let's say we have first name and last name. First name and last name can be used in a table uniquely. Even though they are not part of primary key, they can still be used as a candidate key to identify whether the record is unique or not. First name and last name can be used. Then we have a unique key. Let's say there is a phone number or there is an Aadhaar card number that has been used. So phone number can be used as a unique key, or an Aadhaar card number can be used as a unique key. These values are unique in nature. They cannot be duplicated for another student or another employee. So that is what will be a unique key. And what is a foreign key? If there are two or three tables and one key of one table refers to the primary key of another table, there is a relationship, and that relationship is defined by the foreign key. One key in a one table is referring to the primary key of another table. That would become a foreign key, right? So these are the different keys that we have. And as we go further, we'll look at examples and other aspects of these. So that is why keys would be important. This would become the fundamentals. And then next thing would be essentially what is called as normalization. Now, in order to make sure that we have data correctly, consistently, and we maintain a nice way of dealing with data so that we can remove redundancy from the tables. Now, if you look at our items table that we defined in MySQL Workbench, using MySQL Workbench, items had a lot of duplicate values. That kind of thing should not be allowed in a database. And one of the core rules also mentions that, right? So we would do not want to have duplicate values, or there should be not be any redundancy of the data. If we want to make sure that is not allowed, we can use what are called as normal forms. If we go by these normal forms, we can make the database design very well. There are different kind of normal forms. We have first normal form, we have second normal form, we have third normal form. And after third normal form, there was one person called as RF Boyce who introduced a certain normal form using the CORD rules or what was proposed by CORD. And this is called as BCNF. And this is generally used in the OLAP systems, right? So OLAP systems, we use BCNF where we denormalize or normalization is removed, and that is what would be BCNF. And beyond this, we have fourth normal form, fifth normal form, and the sixth normal form. These are various normal forms that are available. And as we go further, we'll look at each of them using the examples for the keys as well. We'll look at all of these as we go further, right? And we'll start designing our tables, or we'll try to insert data into our tables based on these rules or these normal forms, and then try to run queries on top of them. We'll start dealing with more than one table rather than just dealing with one table. As we go further, we'll do some joins, etc., and see how these normal forms are helping us to design the tables. All right. So for today, we'll stop here. Any questions till whatever we did today? All right. So if there are no questions, then thank you so much. See you tomorrow. Bye-bye. Good night.